You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Ocean plastics, facts and falsehoods. Few topics arouse as much emotion as that of plastic waste in our planet's oceans. Most of this comes from familiar images of mangled sea life, turtles with shells misshapen by six-pack rings, an albatross skeleton bursting with plastic bottle caps. Pop media shows film of waterways choked with floating plastics. Culture responds with Silicon Valley-funded efforts to clean up the oceans with novel machines. Activists push through legislation to ban plastic bags and straws. Through it all, science agencies have provided a steady stream of research and data quantifying the size and scope of the problem. Today we're going to lay out as much of this as we can to see how well the existing cultural response is matched to what the data tell us, and also see whether there might be other initiatives that are better optimized to the true problems. A surprise conclusion which may raise a few eyebrows. We're going to follow a bit more structured process than we usually do here on Skeptoid, broken down into three parts. First, we're going to look at how much plastic is in the oceans. Second, we'll try and characterize how big of a problem that actually is. And third, we'll look at what strategies are best fit to solve the real problem. So, part 1. How much plastic is in the oceans? This key question is studied a lot, and there are all kinds of lines of evidence that have to be taken into account. Research ships are constantly sampling the open ocean. Economists and other scientists are constantly looking at how waste is managed, transported, and disposed of all around the world, and how much of it. The distribution is extremely uneven, with almost all of the visible plastic waste close to shore and in harbors, strongly correlated with localities that pollute the most and/or dump at sea, and seasonally correlated with stormwater runoff, a major contributor to trash in the ocean. Half the plastic at sea is buoyant, and half is distributed among the water column. Just under 2/3 of that coastal plastic that makes it into the ocean is eventually transported to open ocean waters. Of that, it takes 1 to 3 years for it to make it to one of the gyres. Now, as fast as the plastic is coming into the ocean, it also has paths out. Basically, permanent sequestration as sediment on the ocean floor. As floating plastic is on its journey to the gyres, very little of it makes it all the way, as the vast majority breaks down under ultraviolet radiation and wave action. Buoyant particles become biofouled, encrusted with microscopic marine life, and they then sink and become sediment. Some gets defouled and re-enters the water column. Some gets ingested by marine organisms, wherein some remains and some is defecated back out, some of which sinks into sequestration and some of which doesn't. Percentages and hard numbers on most of these are either more study is needed or come in range estimates covering an order of magnitude. In short, it's a ferociously complicated question. But the short answer is there is a lot of plastic in the oceans, and with the rise of Asian economies, it is expected to continue growing. Part 2, what kind of a problem does that plastic create? This is the part of our investigation that's nearest and dearest to my heart, using data to properly characterize a problem. All too often, pop culture clings to an emotion-driven caricature of a problem that can be well communicated with sound bites and memes, prompting solutions that are designed for a problem that doesn't exist. That's why it's crucial to gain as accurate of a picture of any problem as possible. The best source I've found for this is the latest report by the NOAA Marine Debris Program, titled Ingestion: Occurrence and Health Effects of Anthropogenic Debris Ingested by Marine Organisms. Freely available online and recommended reading for anyone interested in the topic. There's a link to it on the online transcript for this episode at Skeptoid.com. The report has sections on fish, sea turtles, birds, and marine mammals. It gives extensive links to studies of each in various parts of the world, showing what percentage have been found to have consumed some plastic. For many species in many locations, it's usually around a quarter of animals sampled. Then, the report looks at the potential health impacts, including internal lacerations and lesions, blockages, and toxicants. Retention is also studied, the majority of plastics consumed are passed by the animals, with only a small part retained. Plastics small enough to not cause a blockage are generally inert, like sand, and pass through the system with no ill effects. The frustrating part of this report is that for almost every category, long-term effects are poorly understood and more study is needed. The report notes that public interest in the subject has been rising for 4 decades as reports of what it calls charismatic megafauna, dolphins, sea turtles, etc., with specific injuries from plastic, have become more common. However, despite this rise in interest and a corresponding increase in research, there are few answers. But surprisingly, this goes even farther. In recent years, some studies have been published with conclusive results finding that plastic passing through the digestive system of marine animals is harmless. Toxins that may be present in the plastics are at levels far too low to have any effect. It's not too dissimilar from when a child swallows a tiny plastic toy. It almost always comes out the other end with no harm done. So the best answer to this question, what's the real nature of the problem, is surprisingly that it may not be nearly so bad as we fear, but we really don't know yet. Part 3. What strategies will best address that problem? The first question many of us ask is, how should we go about cleaning that plastic out of the oceans? However, beyond local shoreline cleanups, which are always desirable, it turns out that there is almost no scientific support for open ocean cleanups, on the principle that any meaningful amount of plastic is way too hard to get, all to achieve an unknown benefit. Regarding the garbage patches themselves, NOAA says,
"Since the debris in these areas is so small in size, is constantly being mixed, and is located throughout the water column, removing it proves to be very difficult. For this reason, we generally focus removal efforts on shorelines and coastal areas, before debris has the chance to make it to the open ocean. Prevention is ultimately the key."
This sentiment of prevention being the best response is nearly universal in the science literature. So let's look at how we do that. Step 1 is to determine where the plastic is coming from. To date, the best light shown upon this particular question was published in the journal Science in 2015 by Jambeck et al., Plastic Waste Inputs from Land into the Ocean. Its results, widely reported in the world press, found that the majority of ocean trash comes from just a few nations, all in the Asia-Pacific region. By far, the worst offender is China, which should come as no great surprise, producing about 3 times as much ocean trash as the second worst offender, Indonesia. Indonesia is almost twice as bad as the third worst offender, the Philippines. The rest taper steadily downward from there: Vietnam, Sri Lanka, Thailand, Egypt, Malaysia, Nigeria, Bangladesh. Together, this top 10 is responsible for 70% of all the plastics in the oceans, with China and Indonesia alone accounting for almost half the total. The surprise on the list is the United States. Many people expect to see it near the top of the list of worst polluters, as Americans are responsible for 2.6 kilograms of trash per person per day, more than twice as much as Chinese. However, the U.S. is way down at 20th on the list of plastic ocean polluters, adding less than 1% of the total. The reason is that the United States is among the leaders in responsible waste management. While some 2% of United States waste ends up mismanaged, 76% of Chinese trash does, and many of the world's countries are above 80%. Why would an economic powerhouse like China be the world's worst polluter? Economists call this the environmental Kuznets curve, named for the Belarusian-American economist Simon Kuznets. In developing nations, pollution worsens as per capita income increases and consumer purchases rise. Then, as per capita income increases more, investment begins to be made into the environment and pollution declines. The United States is on the high-income, low-pollution end of that curve, while China is in the middle income point with maximum pollution. We expect to see India and Africa produce more pollution as their per capita income rises toward that same part of the curve. Thus, places like that are prime targets for strategic investment in waste management. This raises the next question: how can we help? We're bombarded daily by bans on plastic bags and straws and other local initiatives. Are these useful responses? The answer to this brings us to the next surprise. Recall Skeptoid number 419 on slacktivism, in which we found that acts of token support ultimately harm effective activism. While supporters of initiatives like bans on plastic bags and straws in the United States generally acknowledge that their actions don't do much to clean up the ocean gyres, they may feel that they're still setting a good example by being environmentally conscious, and feel that every little bit helps. Yet, while this sentiment is spot on, research has shown that taking these actions has the opposite of the desired effect. A 2014 article in the Journal of Consumer Research titled "The Nature of Slacktivism: How the Social Observability of an Initial Act of Token Support Affects Subsequent Pro-Social Action" found that such acts tend to satisfy a person's desire to help, and that those people are then far less likely to take more effective action than are people who avoided taking token actions. So if you want to buy a reusable straw or reusable grocery bags, that's great, but always try to follow it up with activism and dollars that strike where it counts. Okay, so how do we do that? Can we support organizations that are working to modernize waste management in the offending nations? Unfortunately, there seem to be very few such initiatives in which foreign individuals can meaningfully participate. Initiatives truly addressing the cause of the problem, dealing with the heavy lifting at the industry level that's required, are all handled at the governmental and international level. The American Council on Science and Health sums it up best. You aren't the problem. Asia is. Okay, so let's put a conclusion on this. There are still meaningful ways you can help with your wallet, if you're willing to think a little bit outside the box. And this is where we look back at our finding a few moments ago that the impacts of ocean plastic are probably less than we fear. In fact, research is clear that among the problems facing our oceans, there are at least two that are greater immediate threats than plastic waste: climate change and overfishing. It's easy for foreigners to help with both of these causes. So, although it sounds both counterintuitive and dissatisfying, if you have limited dollars to spend and want to help with ocean health, focus on fighting climate change and overfishing instead. For now, science shows that's the best way you can help our oceans recover. It's not the conclusion most listeners were hoping for, but it is data-driven. Good luck, fair winds, and following seas. A great big Skeptoid shout-out to premium members Sean Gill, Paolo Ripamonti, Pilot Josh, who is listening whenever he's not spreading chemtrails, and of course, the Big G. Get your shout-out by signing into the members portal at Skeptoid.com and let everyone know that you think this material is worth supporting. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.